Suppose we have a triangle, and this is the external angle bisector of this angle. It intersects this side here, and we label this side as M, this as N, this A, and this B. Then we're going to prove that M divided by N equals B divided by A. If the angles of the triangle are alpha, beta, and gamma, then this angle equals 90 minus gamma over 2. And so we can apply the law of sines for this triangle and this triangle. And then we get M divided by N equals the sine of this angle divided by the sine of this angle. So sine of 90 plus gamma over 2 divided by sine of 90 minus gamma over 2, which is here, times the sine of this angle divided by the sine of this angle. So sine of beta divided by sine of alpha. And now notice that sine of 90 plus gamma over 2 equals sine of 90 minus gamma over 2, because the sum of 90 plus gamma over 2 and 90 minus gamma over 2 is 180 degrees. And therefore, we can cancel out these two expressions. And sine of beta divided by sine of alpha, we know from the sine law from this triangle, equals b divided by a. And so m divided by n equals b divided by a. We can rewrite this expression like that, and then we can use the same mnemonic we used for Cheva and Menelaus theorems. Put a multiplication sign next to this vertex, and a division sign here and here. Then m divided by n times a divided by b, and we come back from where we started. Therefore, this expression equals 1. Here's the optional problem. We have a triangle, and this here is the external angle bisector of this angle. This is the internal angle bisector of this angle, and this here is the internal angle bisector of this angle. They intersect the opposite sides of the triangle, respectively at this point, and this point. We need to prove that these 3 points lie on a straight line. And here's the solution. Let the sides of the triangle be C, A, and B. Let this distance be D, this one be E, this one F, G, M, and N. From the property of the external angle bisector, we have that D divided by E equals B divided by A, which is written here. From the property of the internal angle bisector, we have that F divided by G equals C divided by B, so this is written here. And finally, from the same property, but applied to this angle bisector, we have that M divided by N equals A divided by C, which is written here. And now we can take these 3 equalities and multiply them together. The C cancels out here, the A cancels out here, and the B cancels out here. What is left is the left-hand side of all the 3 equations multiplied together equals 1. But this is exactly the statement of Menelaus' theorem for this triangle and these 3 points that we need to prove lie on a straight line, because that's exactly D divided by E times F divided by G times M divided by N. And so, since we know that this expression equals 1, by Menelaus' theorem it follows that this point, and this point lie on a straight line as desired.